Hi guys, here's the end of the year worksheet that we talked about. First of all, make sure, as it says up here, that you have your periodic table and your notes out. And I have other podcasts, of course, on the portal and on YouTube, and a couple more I think I'm going to put on. So in case you run into problems there. First of all, we're going to write formulas for the 7 diatomic molecules. Remember, the diatomic molecules are the molecules that are formed because the element is so reactive that it's never found by itself in nature. If it's not bonded with something else, it bonds with itself, another atom of itself. And so on the periodic table, we start with nitrogen, or hydrogen rather, and so I'm going to write that as H subscript 2. Then we go over to nitrogen, N2, then we have oxygen, fluorine, chlorine, and bromine, and iodine. The 7 diatomic molecules. Now, excuse me. Then I go through some things here about covalent compounds, sharing, et cetera, and I'm not going to go over these things with you. Oops. We'll just move on to the next one. Whoops. All right, I'm back. We have here methane, it's CH4. That's 1 atom of carbon, and it is 4 of hydrogen. And this is a covalent compound because they are both nonmetals. Because it's covalent, it's a molecule. How many molecules or formula units are shown? Just 1. There's no coefficient here, so we just have 1 molecule. How many of each element are present? Carbon has 1, and hydrogen has 4. How many total atoms or ions are present? Altogether, we have 5 for hydrogen and 1 carbon. And the name of this substance, this is covalent, so it uses the prefixes. And so we name this carbon monohydride. Okay. Here's our next one. We have 8 of these. We have to say, is it ionic or covalent? It's ionic. How do we know it's ionic? It has a metal in it, aluminum. Well, it's actually a metalloid, but we treat it like a metal. So it's ionic. Therefore, it is a formula unit. There are 8 formula units, which you can see from that coefficient right there. And then you look at how many of each element are present. And so we're going to do here aluminum. You'll notice by the subscript, the 2 behind the aluminum says we have 2 aluminum here, but then we have to multiply that by 8. So we have 16 aluminum. And then we have 3 of the sulfur, because of this subscript out here. So there we have 8, 16, 24. And then, last but not least, there's always oxygen. And we have 12, 4 times 3 is 12, times 8, which is 96. So then it says how many total atoms or ions are present. Basically, you would just add these up, these here, and you would say 136. The name of this substance, this is ionic. Aluminum only has a single oxidation state, so its name is aluminum and sulfate. And the sulfate, of course, is a polyatomic ion. Okay, identify each of the following as either atom, ion, molecule, or formula unit. So let's go ahead and do this. Here we have magnesium oxide. Magnesium is a metal, and there's two elements present, so it's going to be D. It's going to be the formula unit. And over here, calcium with a +2 charge. That's going to be B. It's going to be an ion because it's a charged particle. Fr2s for C down here, we are going to have that be D again because this is francium, and that is a metal. And so it's going to be a formula unit. And over here we have CO2, and that's a covalent compound, carbon and oxygen, and so it's going to be C, a molecule. Number 5, what happens to valence electrons when an ionic bond is formed? They are transferred. From the metal to the nonmetal. When a covalent bond shared between nonmetals. Okay? Okay, on this one, I put a periodic table down here, which you obviously can't see real well. The number 7 says, name 4 noble gases. And that would be, any of the group 18. So we would have helium, neon, argon, krypton, xenon, or radon would be noble gases. And if you look at this, this is actually a really nice periodic table. I like it. And you can see the colors here. This is noble gas, and they're blue. And then it says name 4 halogens, and I'm going to put over here that these are group 18. These are group 17. And so it's going to be your really reactive halogens, fluorine, chlorine, bromine, iodine, so on and so forth. And you can see that right here for the color. For alkaline earth metals, this is group 2 over here. And so beryllium, magnesium, calcium, so on and so forth. Transition elements, these are the transition elements down in here. And so it's going to be the Bs. Inner transition elements, you can't see those on this periodic table, but as you know, they're down below, they're pulled out below. So, also called rare earth elements. Alkaline metals, the alkaline metals are group 1 with the exception of hydrogen, of course. They are the most reactive metals on the periodic table, and they are orange here. And so they are going to be group 1. There we go. Okay, that's slide 5 of 5. And so I'm going to go ahead and sign off here and pull up part 2. If you have any questions, remember to let me know.